Okay, this is the last time we see Sophie, I promise. Here's a very tricky question. How many pots must Sophie use to be 99.99% sure that at least one seed will germinate? Well, first we have to recognize that 99.99% is really 0.9999. So I want to use that in probability. They gave it to me as a percent, and I convert it to a decimal. Well, what does this mean? At least one will germinate. Well, I have to understand that 1 minus the probability that none germinate, or 0 germinate, is what I'm looking for. The probability that at least one germinates is the same as 1, or 100%, minus the only situation where at least one germinates. I'm sorry, the only situation we have to guard against, if we're talking about at least one germinating, is the case where none germinates. If I take 100% minus the only case where none germinate, then I get the probability that 1, or 2, or 3, or 4, or as long as it's not 0, germinate. Well, 1 minus this probability represents the probability that at least one germinate, and this is going to be at least 99.99. So that's at least 0.9999. Well, what does this mean? This is 1 minus the probability that none germinate would be 10C. I want none to germinate, 0, and that's going to be 0.8 to the 0. Whatever's there goes there. 0.2 is the probability of failure to the 10. So we're going to pick up here in a second. The key with this problem is seeing that the probability that at least one germinates greater than 0.9999 really means, well, that's the same as 1 minus the probability that 0 germinate. Again, at least one germinate means 1, or 2, or 3, or 4, or 5, etc. all the way up to 10 germinate. Which is the only possibility we can't have there is when 0 germinates. So if we take the whole probability of 1 minus the possibility that 0 germinates, we'll get the probability that at least 1 germinates. This is a key concept you see again and again in probability. Well, this is going to be 1 minus the probability that 0 germinate is NC0 of 0.8 to the 0, 0.2 to the n minus 0, which is n, is greater or equal to 0.9999. Why did I do that? Well, because they're saying, how many trials do we have to do to ensure that we're 99.99% certain here? Well, we don't know the number of trials. I don't know that. But I do know that NC0 is always going to be 1. C with the 0 there is always going to be 1. And I know that 0.8 to the 0 is 1. So this simplifies to 1 minus 0.2 to the n is greater or equal to 0.9999. Notice 0.8 to the 0 is 1. C0, anytime you see a 0 there, that's going to go to 1 as well. I can subtract 1 from both sides and I get negative 0.2 to the n is greater or equal to 0.0001, and that's a negative. I can divide both sides by negative 1. When I do that, I have to change the inequality sign, and my negative signs disappear, or they cancel out, whatever you want to think of them. But remember, when you divide or multiply by a negative, you have to change that inequality, switch the sense of the inequality. Well, here's a good review. How do we solve problems? This is an exponential problem. How do I undo exponents? Take the log of both sides. Log of what? Log 0.2 works for me. Log 0.2. Log 0.2 of 0.2 to the n. This goes away, and we're left with n is less than or equal to, I have log 0.2 of 0.0001. Remember, that number there cannot be negative. Change of base formula says this is log base 10 of 0.0001 over log base 10 of 0.2. Remember, when you don't write anything there, you can assume that we're talking base 10. I switched the base by using my change of base formula, and finally I get n is less than or equal to 5.72. That's the number of trials. So realistically, we have to say n is less than or equal to 6. Well, we say less than 6. That's my final answer.